Good morning, all of you. Welcome to Sri Jayendra Rank Zone. So now we are going to discuss redox reactions. In the previous lecture, we have done already oxidation number and how to balance redox reactions by using ion electron method and also oxidation number method. Now in this class, we are going to discuss the last topic in this chapter, that is balancing redox reactions by partial equation method. Let us start now. It's very important. So this is the last session in redox reaction. I told you already I told you it is a very small chapter, so very important chapter, but its chapter is very small. So we are going to discuss now. Yes, yes. So balancing of redox reaction by partial equation method. This is the last topic in this chapter, that is called balancing of redox reaction by partial equation method. So what is this partial equation method we are discussing now? In this method, the redox reaction is split into two partial equations, but it's not like two half reactions. It is two partial equations. These partial equations are balanced by hit and trial method. And finally, the partial equations are added to get the final balanced equation. By writing the partial equations, intermediates like nascent oxygen or nascent hydrogen are used. While writing the partial equations, we have to write the intermediates. It's very, very important. Here, the intermediates will be there, like nascent oxygen. Nascent oxygen is nothing but what? It's highly reactive. It is also called as just born oxygen, or just born hydrogen. These are nothing but this will form in the as intermediates in the chemical equation. This also we should include. Then only the equation is getting balanced. Let us see how it will get balanced right now. Hydrogen peroxide is an oxidizing agent. You know, oxidation reactions of hydrogen peroxide, H2O2. Hydrogen peroxide is an oxidizing agent. The partial equation for oxidizing nature of hydrogen peroxide is given by H2O2 decomposes to form H2O plus nascent oxygen. This bracket O is nothing but what? This is called nascent oxygen. It is just one oxygen which is highly reactive. So this is called nascent oxygen, which is also called as just one oxygen. It is highly reactive. The nascent oxygen is combined with the reducing agent to form the products. The nascent oxygen is combined with the reducing agent to form the products. So let us see how the equations will get balanced here. This is nothing but oxidation reactions of hydrogen peroxide. It's very, very important for advanced level. Now, let us see. Balance the following equation by partial equation method. So this is the equation actually. Hydrogen peroxide combines iron sulfate, that is ferrous sulfate, along with sulfuric acid to form ferric sulfate along with water. So this is a balanced equation. This is the equation which we are going to do balancing now. Let us see. Since hydrogen peroxide, we already know it decomposes to form H2O plus nascent oxygen. So this nascent oxygen combines with iron sulfate, that is ferric sulfate, because here two ions are there. So here we are adding two ions, 2FeSO4 plus H2SO4 plus nascent oxygen forms Fe2SO4 taken this plus H2O. And by adding these two equations, we get final equation 2FeSO4 plus H2SO4 plus H2O2 gives us to Fe2SO4 taken as plus H2O. Suppose if you do balancing here, if you want to do balancing here, how many hydrogens here? Two hydrogens. How many oxygens? Two oxygens. And here 4, 3 is 12. And here 2 plus 4, 6 plus 4, 10. So two more oxygens we need to get. But if you write 2 here, you'll not get the exact answer because 2FeSO4. So in this way, we'll do balancing the following equation by partial equation method. This partial equation is very important. So this is called hit and trial method for balancing the partial equations. I hope it is clear. Yes. So hydrogen peroxide plus FeSO4 plus H2SO4 gives us to Fe2SO4 taken this plus H2O. So in this reaction, the intermediate formed is nascent oxygen. This also they'll ask in the examination question. So H2O2 decomposes to form H2O plus nascent oxygen. This nascent oxygen combines ferric sulfate and forms ferrous sulfate and forms ferric sulfate. So by adding these two equations, finally you'll get the answer. 2FeSO4, H2SO4 as it is. Nascent oxygen will be converted into H2O2, gives us to Fe2SO4 taken this plus 2H2O. So this is called balancing redox reaction by partial equation method. Next, oxidation reactions of potassium permanganate solution. As I already told in the previous session, that potassium permanganate is used for titration, that is volumetric analysis. It is used for titrations to estimate the concentration of the solution, that is called titration. So titration, it is used as it is used for titrations, which is also called as to estimate the concentration of unknown solution, the concentration of unknown solution. So for this, we'll use titration method to estimate the concentration of unknown solution. So in this method, what happens? Potassium permanganate is one of the strongest oxidizing agents. It brings about oxidation to others and itself undergoes reduction by using chemical reactions. It behaves as an oxidizing agent in acidic medium, neutral medium, as well as alkaline medium. The partial equations for oxidizing property of potassium permanganate are these are all the partial equations they'll ask in examination. Please note it down. So potassium permanganate in acidic medium forms potassium sulfate, manganese sulfate, water along with nascent oxygen. And in basic medium, potassium permanganate combines with base. Here acidic medium is with acid and basic medium is with base. So potassium permanganate combines with base to form potassium manganate along with water along with nascent oxygen, basic medium. In neutral medium, potassium permanganate combines with water and forms manganese dioxide, potassium hydroxide, and oxygen. All these three reactions are very, very important because they'll ask the equivalent weight of potassium permanganate from these three equations. Equivalent weight. They'll ask what? Equivalent weight. Equivalent weight. How to calculate equivalent weight? We have already discussed in the basic concepts of chemistry. Now here, if you see the here in the oxygen state of manganese is +7. In acidic medium, it changes to +2. So the equivalent weight of potassium permanganate in acidic medium is potassium permanganate in acidic medium is equal to in H plus ions, that is acidic medium, is equal to molecular weight, that is total weight of the potassium permanganate, by number of electrons gained or lost. Here it is gain, it is reduction, so it is nothing but 7 changes to 2. It is undergoing reduction, so it is number of electrons gained is 5. So molecular weight by 5. Like that, you will get the questions in examinations. So potassium permanganate in acidic medium changes to manganese sulfate. So it is changing from +7 state to +2 state. This is very, very important. So +7 changes to +2 state so that it becomes molecular weight by 5. So equivalent weight of potassium permanganate in acidic medium is equal to molecular weight by 5. This they'll ask in the examination. And you know the molecular weight of potassium permanganate, that is 296. So like that you will get. So potassium 39, manganese, and each and every atomic weight of potassium, manganese, and oxygen will be given to you. So based on that, you have to find the molecular weight by using the formula potassium 1 potassium. So 39 plus manganese 1 atom, atomic weight of manganese you have to take, that is 55, and plus oxygen 16. 16 4 is 64. So we have to add all these things and you have to find out the answer. So this is called potassium permanganate. So that is equal to molecular weight is equal to how much? That is 39 plus 55 plus 64 by 5, because 39 is the atomic weight of potassium, manganese 45, and 16 is the atomic weight of oxygen. But since 4 oxygens are there in this, how many oxygens? 4 oxygens. So 16 4 is 64 by 5. So like these questions they'll ask, even not only this, they ask even the balance equations also. So that's why these reactions are very important. Let us see in basic medium how does it take place. Here the oxygen state of manganese is +7 and changes to K to 2 plus x minus 8 is equal to 0. So 2 plus x minus 8 is equal to 0 means here manganese 2 plus x minus 8 is equal to 0. That is 2 minus 8 is x minus 6. So 8 is 0. So x is equal to +6. So from +7 it changes to +6. So in basic medium, the equivalent weight of potassium permanganate is equal to molecular weight by 1, because only one electron change, 7 to 6. So equivalent weight is equal to in basic medium, equivalent weight of potassium permanganate in basic medium is equal to in basic medium is equal to molecular weight by 1. So in the same way, neutral medium, here what happens? +7 changes to MnO2 +4. So in neutral medium, it is equivalent weight is equal to molecular weight by 3. So all these three topics are very important, these three reactions. So in basic medium, what happens? Potassium permanganate changes to potassium manganate along with water and nascent oxygen. Potassium permanganate in a neutral medium changes, combines with water. Neutral medium is water, so it combines with water and forms manganese dioxide, potassium hydroxide along with nascent oxygen. So this they'll ask equivalent weight concept. So here this concept they will take and apply in basic concepts of chemistry. So what is the equivalent weight of potassium permanganate in acidic medium? It is equal to molecular weight by 5. What is the equivalent weight of potassium permanganate in basic medium? It is equal to molecular weight by 1. And what is the equivalent weight of potassium permanganate in neutral medium? It is equal to molecular weight by 3. I hope it is clear. So it is very, very important. So the partial equations for oxidizing property of KMnO4 are 2 KMnO4 changes plus combines with 3 moles of acid, that is sulfuric acid, to form potassium sulfate, manganese sulfate, 2 moles of manganese sulfate, and 3 moles of water plus 5 moles of nascent oxygen. 5 moles here, that's why the difference is 5. And here it is 1 mole of oxygen, that's why the difference is 1. And here 3 moles of oxygen it should form. So it should form 3 moles of oxygen, and the difference is 3. I hope it is clear. So please note down all these points in your classwork. You can understand it better. So this is the partial equations for oxidizing property of potassium permanganate. So potassium permanganate, how it behaves in acidic medium and how it combines with base and how it is formed in neutral medium. All the three are given to you. Let us see now examples. Balance the following equation by partial equation method. So that is nothing but potassium permanganate combines sulfuric acid and forms with ferrous sulfate. It forms potassium sulfate, manganese sulfate. These two are common, and Fe2SO4 taken this because this ferrous sulfate changes to ferric sulfate plus water. Simple it is. So in this again nascent oxygen is formed. So first equation as is will write, that is potassium permanganate combines H2SO4 and forms K2SO4, MnSO4, 3H2O plus 5 oxygens, that is nascent oxygens. These 5 nascent oxygens nothing but combines with ferrous sulfate and H2SO4 and forms ferric sulfate plus water into 5. So by using this equation, partial method, we can do it because 5 oxygens is here, so we have to multiply with 5 here. Why we are multiplying with 5? Because 5 nascent oxygens are formed and in the equation is only one it is forming. So simply you have to multiply with 5. So the final equation, the balanced equation is 10 FeSO4 plus 8 H2SO4 plus 2 KMnO4 gives rise to K2SO4 plus 2 MnSO4 plus 5 Fe2SO4 taking place plus 8 H2O. Simply you have to multiply this equation with 5. So 5 H2O and 3 H2O. 5 plus 3, it becomes 8 H2O and 5 Fe2SO4 as it is, and 2 MnSO4 for this no multiplication. So 2 MnSO4 as it is and K2SO4 also as it is. Whereas here then your reactant side 2 FeSO4 2 into 5 it is equal to 10, and H2SO4 5 into 5, H2SO4 it is 5 H2SO4 plus 3 H2SO4 becomes totally 8 H2SO4 plus 2 KMnO4. How we got here 3 H2SO4? Simply it is nothing but SO4 taken thrice. Since SO4 taken thrice is there, so we have to multiply with 3. So here I am keeping 3. And since iron is 2, so simply you will keep 2. So after doing that also, it will not be getting balanced. So to get balance, we should know the intermediate equation, that is partial equation. This is the partial equation. Very, very important. This partial equation. Without knowing partial equation, you cannot balance. So we have to remember these partial equations in acidic medium, basic medium, as well as in neutral medium. I hope it is clear. So in acidic medium, 5 nascent oxygens are formed. In basic medium, only 1 nascent oxygen. And in neutral medium, 3 nascent oxygens are formed. Now let us see next example. Balance the following equation by partial equation method. This is basic medium. So here basic medium means first we'll do the skeletal equation balance. So KMnO4 since K2SO4, so 2 KMnO4 here because potassium is 2 and SO3 is there and SO4 is here. KMnO4, K2 and MnO4. So K and K, 2 Ks are there. So straight away we'll write here 4K. Just wrapping it now. First, we have to see only balance equation and KOH, K2SO4, K, and K2. Total 4 are there, and here also 4. Manganese 1, manganese 1. Oxygens 4, oxygens 4. 4 plus 1, 5, 5 plus 3 is 8. But here 4 plus 1, 5, 5 plus 4, 9. So one more nascent oxygen is formed. That's why it's still here 4 plus 4, 8, 8 plus 1, 9. And here 3 plus 1, 4, 4 plus 4, 8. So one more nascent oxygen should be formed. So that nascent oxygen will be attacking this KOH. I hope it is clear. Let us see the answer now. So KMnO4 combines with 2KOH because 2K, because potassium hydroxide is 2. So straight away we will write here 2. So 2KOH and forms K2MnO4. K2MnO4 plus H2O plus nascent oxygen. This equation is the basic equation. You have to remember this equation 100%. Then this K2SO3 combines with that nascent oxygen because it has to change to K2SO4. So that nascent oxygen K2SO4. And straight away the equation becomes like this. So this is the equation in basic medium. I hope it is clear. This is called partial equation method, balancing the following equation by partial equation method. So without knowing the intermediate, we cannot do the balancing easily because this is the intermediate formed. And this intermediate formed is only one atom of nascent oxygen. In the previous question, 5 atoms of nascent oxygen because it is acidic medium. But in this question, only one atom of nascent oxygen because here itself clearly we can say SO3 changes to SO4. SO3 changes to SO4 means one more oxygen should be there. I hope it is clear. So next, balance the following equation by partial equation method, that is in neutral medium. Potassium permanganate combines with potassium nitrate along with water to form potassium nitrite, and this is nitrite and nitrate, potassium nitrite and potassium nitrate, and manganese MnO2. Here N should be smaller. It has written wrong. So here N should be smaller. So this should be M, capital M, NO2 plus KOH, potassium hydroxide. So these are the equations now. Now in this case, how it is formed, as already we know the equation. So let us see the equation now. So potassium permanganate first combines with water. This potassium permanganate combines with water to form 2 moles of manganese dioxide, 2 moles of potassium hydroxide, and 3 nascent oxygens. As I told you, in neutral medium, it is how many oxygens? 3 nascent oxygens. Because itself we can see here 4 plus 2, 6, 6 plus 1, 7. And here 3 plus 2, 5, 5 plus 1, 6. So one more oxygen is less, but here 2 KMnO4. So automatically it become, so KNO2 plus nascent oxygen into KNO3 into 3. So final equation becomes 2 KMnO4 plus H2O plus 3 KNO2 plus 3 KNO3 plus 2 N1O2 plus 2 KOH. So this nascent oxygen only is the key factor to multiply. So automatically you'll get the answer. I hope it is clear. So this balancing the following equation by partial equation method is very, very important. This is the last concept in this chapter. So we are going to discuss. So balancing the following equation by partial equation method, potassium permanganate combines with potassium nitrite and water, that is neutral medium. And neutral medium, we already know potassium permanganate releases 3 nascent oxygens. How many oxygens? 3 nascent oxygens. In acidic medium, potassium permanganate releases how many nascent oxygens? 5 nascent oxygens. In basic medium, potassium permanganate releases how many nascent oxygens? 1 nascent oxygen. So from that only we can find the remaining answer easily. I hope it is clear. So whatever the nascent oxygen is formed, that will combine with the reactant. The nascent oxygen so formed is combined with the reactant. So the what is the reactant here? KNO2. Because KNO2 is a major reactant. So KNO2, the nascent oxygen combines with 3 moles of nascent oxygen is there. So it is combined with KNO2 and forms KNO3 into 3. So like this, the equation is balanced. I hope it is clear. So potassium permanganate releases 5 nascent oxygens in acidic medium. That's why its equivalent weight is. So you can write it here again. Equivalent weight of potassium permanganate. This equation is very, very important. That's why they'll ask either equivalent weight or they ask the complete equation. So equivalent weight of potassium permanganate in H plus medium is equal to molecular weight by 5. Again, I'm writing this because for your understanding, why it is molecular weight by 5, because it is gaining 5 electrons, because manganese changes from +7 state to +2, and also it releases 5 nascent oxygens. Similarly, equivalent weight of potassium permanganate in basic medium, that is OH minus, is equal to molecular weight by 1 because it is releasing only 1 nascent oxygen. And even if you take manganese +7 state changes to +6, reduction only. So molecular weight by 1. Similarly, potassium permanganate in neutral medium, that is in water, is equal to molecular weight by 3. So these examples they'll ask in the examination for competitive exams. So equivalent weight of potassium permanganate in acidic medium is equal to how much? The equivalent weight of potassium permanganate in basic medium is equal to how much? The equivalent weight of potassium permanganate in neutral medium is equal to this much. And also they'll ask the equations also. All the equations are important. So the intermediate formed in the potassium permanganate reactions is nascent oxygen. Nascent oxygen. I hope it is clear. Very, very important concept. Next, oxidation reactions of potassium dichromate. This is also one more reagent for titration, that is called potassium dichromate K2Cr2O7. This is also used for titrations, volumetric analysis, titration to estimate the concentration of a solution. So for this, how to calculate the oxidation reactions of potassium dichromate, if you know, easily you can find out. So the potassium dichromate is a strong oxidizing agent. It brings about oxidation and undergoes reduction in acidic medium. The Paulsen equation of oxidizing reactions of potassium dichromate is in acidic medium. How does it changes? Chromium from +6 state changes to +3 state, and two chromiums are involved. To total number of electrons, total is equal to, since two chromiums are there, total electron change is 6. 6 electrons are being gained. 6 electrons are gained. So automatically you'll get the equation. So potassium dichromate on reaction with sulfuric acid, it forms potassium sulfate, chromium sulfate along with water and 3 nascent oxygens. 3 nascent oxygens. So this is the basic equation. So for this, how to find equivalent weight of potassium dichromate? Equivalent weight of potassium dichromate is equal to in acidic medium. Equivalent weight of potassium dichromate in acidic medium, that is H plus medium, is equal to molecular weight, that is 296 by 6. Molecular weight by 6. This also they'll ask in examination. This also they'll ask in examination. So these two concepts you have to remember carefully. I hope it is clear. Please note down the equivalent weight of potassium dichromate in acidic medium is equal to molecular weight of 6 because it gains 6 electrons. One chromium is 3. Since two chromiums are there, it is 6. How we got +3 state here? You can say here 2x minus 6 is equal to 0 because sulfate is 2 minus. The charge of sulfate is 2 minus. So 2 into 3 is 6. So 2x minus 6 is equal to 0. 2x is equal to 6 plus x is equal to 3. So it changes from +6 to +3. But two chromiums are involved, so total 6 electrons are gained. Since two chromiums are there in both the equations, 6 electrons are gained. Since 6 electrons are gained, so the equivalent rate of potassium dichromate in H plus medium is equal to molecular weight by 6, that is 294 by 6. How you got 294? Since two potassiums, 39 into 2, chromium 54 into 2, oxygen 16 into 7. So if you do this, 100% you'll get the answer. I hope it is clear. So next, example 5. Balance the following equation by partial equation method, that is potassium dichromate combines sulfuric acid and sodium sulfite to form chromium sulfate, sodium sulfate, and water. Here what happens, it changes sodium sulfite to sodium sulfate. So potassium dichromate changes on in acidic medium combines with sodium sulfite to sodium sulfate. Just bring it again. So here what is it changing? Sodium sulfite. Sodium sulfite. This is sodium sulfite to sodium sulfate. That's why it's a good oxidizing agent. It is bringing oxidation to sodium sulfite to sodium sulfate and itself undergoing reduction. So how to balance this reaction? By using the intermediate formed. So that balancing equation you just see here now. So potassium dichromate combines with 4 molecules of sulfuric acid to form potassium sulfate, chromium sulfate, because here 1 sulfate and here 3 sulfate. So automatically it should form combines with 4 molecules of sulfuric acid. So potassium sulfate combines with 4 molecules of sulfuric acid to form potassium sulfate, chromium sulfate, water along with 3 nascent oxygens. These 3 nascent oxygens combines with sodium sulfate. This is a reactant, only a reactant. So these 3 moles of nascent oxygens combine with sodium sulfate to form sodium sulfate. This for this just addition of oxygen takes place to form. That's why it is undergoing oxidation and it is multiplied with 3. Why? Because 3 nascent oxygens are formed. So automatically it will get 3 moles of sodium sulfate to form 3 moles of sodium sulfate. I hope it is clear. It's very, very important. So this is called balancing the redox reaction by partial equation method. That is balancing of potassium dichromate reaction in acidic medium on it reduces sodium sulfite to sodium sulfate. iodide to iodate, and so on. So many things it will reduce. So this is the basic equation. We have to remember the basic equation. This basic equation is very, very important. I hope it is clear. Next, oxidation reactions of nitric acid. Nitric acid is HNO3, behaves as an oxidizing agent in addition to its acidic behavior. So, in addition to the acidic behavior, nitric acid is also called as an oxidizing agent. So, the extent of oxidation varies with its concentrations. The extent of oxidation varies with its concentration. The partial equations used in oxidizing reactions of nitric acid are given below. So, the nitric acid, when 2 moles of nitric acid are taking, you are getting 1 mole of nascent oxygen, that is H2O, nitrogen dioxide, and that is hot and concentrated. If you take hot and concentrated nitric acid, these reactions are also important in identifying the products. When you take hot and concentrated nitric acid, the products are water, nitrogen dioxide, along with nascent oxygen. When you take neutral medium with water, that is 1:1 nitric acid with water, it forms uh, nitrogen oxide, nitrogen dioxide, nitrogen oxide, and this is called laughing gas, nitrous oxide. Nitrous oxide when very dilute nitric acid. So it is releasing one nascent oxygen, three nascent oxygens, and four nascent oxygens. So this is useful in writing the reactions of nitric acid. These products also they'll ask in the examination. This is called reddish brown color. This is neutral oxide. This is also neutral oxide, but this is acidic oxide. Acidic oxide. So they'll ask questions in any way. So that's why all these points are very, very important. Let us see now. Balance the following equation by partial equation method. Zinc on reaction with concentrated nitric acid forms zinc nitrate along with water plus nitrogen dioxide. See, since it is nothing but concentrated hot and concentrated nitric acid, it forms zinc nitrate plus water plus nitrogen dioxide. Similarly, if you take zinc on reaction with cold and dilute nitric acid, it forms zinc nitrate along with water along with nitrogen oxide or nitrous oxide. Here the product is changed. So let us see now the equation. Since 2 moles of nitric acid combines to form, because NO3 taken twice is there, so we have to write here straight away 2, hit and trial method 2. So 2 moles of nitric acid combines together to form water, decomposes to form water, nitrogen dioxide, nascent oxygen. This nascent oxygen attacks zinc and changes to zinc oxide. This zinc oxide again combines with nitric acid and forms zinc nitrate plus water. So on the whole, four nitric acids are used. So four nitric acid, two nitrogen nitrates, and two nitrogens. So automatically four you will get. So I hope it is clear. This is called hit and trial method of balancing redox reaction by partial equation method. So zinc combines with nascent oxygen. Whatever the nascent oxygen is formed, it will attack the reactant only. So that it converts zinc to zinc oxide first, then zinc oxide changes to zinc nitrate by using nitric acid. Example 7. So here balance the following equation by partial equation method. As I told you, here this is cold and 1:1 dilute nitric acid. That is dilute nitric acid with water. It is not concentrated nitric acid. It is called dilute nitric acid here. Because how I am saying here dilute nitric acid? Because the product formed is nitrogen oxide, neutral oxide. It is neutral oxide. It is nothing but it is not acidic oxide. It is neutral oxide. So the product formed is neutral oxide. So that's why it is nothing but dilute acids. So silver on reaction with dilute acids forms silver nitrate along with water plus nitric oxide. So neutral nitric oxide, that is nitrogen oxide. Let us see the balancing now. So 2 moles of nitric acid. This skeletal equation only we have to remember, then only you can get the answer. So this already we know 2 moles of nitric acid combines to decompose to form water, nitrogen oxide plus 3 moles of nascent oxygen. These 3 moles of nascent oxygen attacks what? Silver, because the silver is the reactant, main reactant. So it attacks silver and forms silver oxide. This silver oxide further combines with nitric acid and forms silver nitrate plus water. So by using all these equations, straight away you'll get the answer 6Ag plus 8HNO3, 6AgNO3 plus 4H2 plus 2. Since all are divisible, so we can take the common factor and finally it forms 3 moles of Ag combined with 4 moles of nitric acid to form 3 moles of silver nitrate plus 2 moles of water plus 1 mole of nitric oxide. 1 mole of nitric oxide. So this is the equation. I hope it is clear. Very, very important. These equations are important for advanced level and also NEET level. So please consider these equations. Next, Balance the following equation by partial equation method. That is, zinc combines with very, very dilute nitric acid and forms nitrous oxide. Nitrous oxide means we can say simply very, very dilute nitric acid. So they'll ask the equations in the examination directly, and formation of nitrogen dioxide, nitrogen oxide, and nitrous oxide. This is also called as laughing gas. What is this called? This is also called as laughing gas, neutral oxide. This again, it is neutral oxide, but it is also called as laughing gas. So with very, very dilute nitric acid to form zinc nitrate plus nitrous oxide plus water. Let us see the balancing of this reaction. By hit and trial method also we can do the balancing of this reaction. So 2 moles of nitric acid combines to form water plus nitrous oxide plus 4 moles of oxygen. These 4 moles of nascent oxygen combines with zinc to form zinc oxide, and the zinc oxide combines with again nitric acid to form zinc nitrate plus water into 4. So 4 moles of zinc, 10 moles of nitric acid, 4 moles of zinc nitrate plus 5H2O plus N2O. So because 4 into zinc oxide, so 4. 4 twos are 8. 8 plus 2 already here, 10. So, and here 4 into zinc nitrate, so 4 moles. And 5 into 4 into water, and here 4 into 1 water. So 4 plus 1, 5 moles of water. And N2O here only 1. So here no N2O, so straight away only 1. So this is the answer. I hope it is clear. So these are nothing but the balancing the following equation, partial equation method. Next, oxidation reactions of halogens. Lastly, this is oxidation reactions of halogens. Halogens acts as an oxidizing agent in the presence of water. Very important. Halogens acts as oxidizing agents in the presence of water only. The partial equation for oxidizing reactions of halogens is halogen. X in the presence nothing but X can be fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, or iodine. So X2 means F2 because they exist as diatomic molecules. So any of these. So when F2 or X2, Cl2, Br2, I2 combines with water, it forms 2 moles of hydrogen acids, that is HF or HCl or HBr or HI plus nascent oxygen. So this nascent oxygen attacks the reactant. Let us see in the balancing equation. Iodine combines sulfur dioxide and water to form hydrogen, that is sulfuric acid plus it brings sulfur dioxide change to sulfuric acid plus hydrogen iodide. So this is the actual equation. Now we'll do balancing because nascent oxygen is formed here again. So iodine combines with water. First, it forms 2 moles of hydrogen iodide plus 1 mole of nascent oxygen. This 1 mole of nascent oxygen attacks sulfur dioxide and forms sulfur trioxide. This sulfur trioxide combines with water and forms H2SO4. So the final equation by adding all these things, so iodine plus SO2 plus 2H2O gives H2, 2HI plus H2SO4. So this is a balanced equation. This is very small equation, so easily we can do balancing by hit and trial method. Only thing is one nascent oxygen is formed as intermediate, and thus that nascent oxygen attacks sulfur dioxide and changes into sulfur trioxide. This sulfur trioxide combines with water and forms sulfuric acid. So from sulfur dioxide changes to sulfuric acid. The oxygen state of sulfur is +4 here and it is +6 here. So reduction, no, it is oxidation, increasing oxidation number, oxidation. So I hope it is clear. Very, very important, all these equations. So next concept in this chapter we'll see now. The same concept we have to do another time. So very, very important this concept. Please note down. And this is the final concept in this chapter now we are going to discuss. After that, we'll do summary of the chapter with some questions. Very, very important. So this chapter is very small. That's why you have completed successfully this chapter in only 3 lectures. These 3 lectures are very, very important. These 3 lectures are very important. So please see that. Once I'll do the conclusion of the chapter, then you can easily understand. Let us see now molecular and ionic equation. So what is this? Molecular and ionic equations. Molecular equations are the equations involving the molecular form of the reactants and products. So example, potassium permanganate combines iron sulfate, that is ferrous sulfate to form ferric sulfate, potassium sulfate, manganese sulfate, and water. Ionic equations are the equations involving ions which are reacting to give products. So these are the ionic equations. So it's the same equation we can write the ionic equation like this. Cr2O7 2 minus C2O4, that is oxalate ion. This is called what? Oxalate ion. C2O4 is called oxalate ion. its charge is -2. Dichromate ion. Dichromate ion combines the oxalate ion in the presence of acid, forms 2Cr plus 6CO2, 7H2O. These equations only they'll give in the examinations. In the place of this and this, they'll keep X and Y and Z like this. So they'll ask the number of molecules in the examination. For that, you need to do balancing. And these equations can be balanced by the following ways. Balancing of molecular equation by oxidation number method. Identify the atoms undergoing change in oxidation number, just like in the previous case. We have to see the atoms undergoing change in oxidation number. Determine the extent of decrease and increase in the oxidation numbers and equalize them by multiplying suitable numbers. Balance all atoms except hydrogen and oxygen. Balance hydrogen and oxygen to get the balance equation. Just like ion electron method, same values, but here no addition of water and no addition of H plus ions. We'll see now here. So balance the following equation by oxidation number method. Sulfur plus HNO3 gives us sulfur dioxide plus NO2 plus H2O. Let us see the first. I write the oxygen states. Sulfur it is 0, hydrogen it is +1, nitrogen it is, so since 1 plus x minus 6 is equal to 0, 1 plus x minus 6, because oxygen is -2 already we know, so x is equal to 5. So nitric acid, nitrogen is +5, sulfur dioxide +4, and nitrogen dioxide +4, and remaining this is same. So the change in oxidation numbers is sulfur is changing from 0 to +4 state, and nitrogen from +5 to +4 state. So this is decrease in oxidation number. This is decrease in oxidation number, and this is increase in oxidation number. Increase in oxidation number. Decrease in oxidation number as well as increase in oxidation number. So it is 0 to +4. This is increase. Sulfur is undergoing oxidation and nitric acid is undergoing reduction. So it is plus nitrogen dioxide. So this is acidic medium. So again, this is nascent oxygen is formed again here. So let us see the answer now. So sulfur dioxide combines 4 moles of nitric acid. Why? Because 4, here 2 oxygen, 2 hydrogens are there, and changes from +5 to +4. So nitrogen is changing from +5 to +4, sorry, +4. Nitrogen is changing from, and here by seeing just hit and trial method only, there's one sulfur here, one sulfur, one nitrogen, but here one nitrogen, and 3 oxygens, and here 2 plus 1, 3, 3 plus 2, 5 oxygen. So definitely we have to balance oxygen as well as hydrogens, only one hydrogen, 2 hydrogens. So we have to balance hydrogen and oxygen. So by doing crisscross method, so sulfur combines 4 moles of nitric acid to form sulfur dioxide plus 4 moles of nitrogen dioxide, because 4 nitrogens are there, plus 2 moles of water. Just like this you have to do. Why we got here 4 moles? Because from nitrogen, it is changing from +5 state to +4. It is should be when nitrogen dioxide is formed, automatically we should know that nascent oxygen is formed. When nascent oxygen is formed, it is how many? Is 1. So it is equal to 4. So we have to do like hit and trial method, oxidation number method. Next, second example. Balance the following equation by oxidation number method. This is potassium dichromate. So potassium permanganate combines chromium sulfate along with water. It forms hydrogen chromate, H2SO4, manganese sulfate plus potassium sulfate. So identify the one which is undergoing change in oxygen state. That is manganese +7. This is neutral medium. So it is changing to manganese +2. So changes from +7 to +2. Chromium +6, because 2 plus 6, 2x minus 6 is equal to 0, implies 2x is equal to 6. So x is equal to +3. So +3 changes to +6. So since 2 chromiums are involved, total electron change is 6. So it is increase in oxidation number, and this is decrease in oxidation number. Remaining all, there is no change. So decrease in oxidation number, increase in oxidation number. So if you could do balancing of only chromiums and manganese, you'll get the answer. So, and after balancing chromium and manganese, then we have to balance potassium. So since 2 potassiums are there, so definitely we have to use how many potassiums? 2 potassium permanganate. So since 2 manganese, so 2 manganese sulfates. So sulfates are 3 here, but here it is 2 plus 1, 3. Next we have chromiums 2. So chromiums 2. Now finally we have to balance oxygen. Finally we have to balance oxygen as well as hydrogen. Hydrogen, let us see how many hydrogens, 2 hydrogens, but here 2 plus 2, 4, 4 plus only 4. So here if you add 2 H2O. But we have to see the oxygens also. Here 2 fours are 8 and 4 3 are 12. 12 plus 8, 20 and 21. And here 7 plus 4, 11, 11 plus 8, 19, 19 plus 4, 23. So this side it is more. So if we keep oxygens here, hydrogens, so automatically you'll get the answer. So finally we have to do balancing for oxygen and hydrogen only. Let us see the answer now. So 6 KMnO4 plus 5 Cr2 SO4 taking this plus 11 H2O gives H2, 5 H2 Cr2O7, 6 H2 is SO4 plus 6 MnSO4 plus 3 KTSO4. So this is the equation, final equation. So we have to learn these examples, very, very important. So why it is forming? Because in neutral medium, it potassium permanganate releases how many nascent oxygens? 3 nascent oxygens. That 3 nascent oxygens combines with these chromiums, and finally it forms the answer like this. Balance the following equation by oxidation number method. KNO2 plus Ka plus HCl gives us KCl plus I2 plus NO plus H2O. So here NO is forming. So potassium iodide. So 2 moles of potassium iodide, potassium nitrite changes to potassium chloride. Potassium iodide plus 4 HCl forms like this. So here also you can identify the oxygen state of nitrogen. So the oxygen state of nitrogen here is how much it is? Plus 3. Because 1 minus 4 is equal to 0. So it becomes minus 3. So x minus 3 is equal to 0 means x is equal to plus 3. And what is the oxygen state of nitrogen here? Plus 2. So nitrogen decreasing. And here iodine minus 1. And here iodine 0. So it is increasing oxidation number and decreasing oxidation number. So we have to multiply this only crisscross method. So 3 and minus 1 to 0, 1. So difference is 2. So 2 moles, 2 moles, 4 moles, because it is already 2 is here. So 4 KCl like this here again. So I hope it is clear. So this is called balancing the following equation by oxidation number method. Very, very important. Balancing of molecular equation by ion electron method. This is again the same thing like ion electron method. The given molecular equation is reduced to ionic equation first. The reduction half and oxidation half reactions are separated. Finally, add the two balanced half reactions to get the balanced ionic equation. This balanced ionic equation is converted back to molecular equation. Let us see how. Balance the following equation by ion electron method. So here, first I write the ion here. So K2Cr2O7. So Cr2O7 2 minus plus iodine minus. In the presence of acid, it forms Cr plus 3 plus iodine, and remaining as neutral water is going to take like this. So iodine 0. So here we have to take iodine 0. So this is acidic medium. Since acidic medium, the presence of H plus, since it is acidic medium. So straight away we have to do the balancing equation by using acidic medium. So we can take the Cr2O7. So here what is the oxygen state of chromium here? Plus 6. And here it is changed to plus 3. Iodine minus 1, it is 0. So minus 1 to 0. Just only these are the things which are going to change. First, we have to balance this by using ion electron method. So let us see how to find ion electron method as we discussed in the previous lecture. So just same like this only. So first we'll write oxidation half reaction, and next we'll write reduction half reaction. What is oxidation half reaction? So which is increasing here, minus 1 to 0. So iodine minus changes to iodine. This is oxidation half reaction. What is reduction half reaction? Cr2O7 2 minus changes to Cr plus 3. This is reduction half reaction. So now iodine minus 2 moles of iodine. So this is oxidation. So 2 moles of iodine changes to iodine plus how many electrons change? Only 2 electrons because 2 iodines are there. So since it is losing of electrons, because losing of electrons is called oxidation, increasing oxidation number. So it is minus to 0. So it is only 2 electrons. Similarly, we'll write for reduction. So Cr2O7 plus 2. So first we'll write here 2. So it should gain how many electrons? 6 electrons. So first we'll write Cr2O7 2 minus gain 6 electrons to form 2 Cr plus 3. How many Cr plus 3? 2 Cr plus 3. Now, to the side deficit of oxygen, add equal number of water molecules. So this becomes Cr2O7 2 minus plus 6 electrons gives rise to, here I'm keeping the gap. Why we have kept the gap also I'll tell you. How many water molecules we have to add? 7 water molecules. And as we are adding 7 water molecules, we have to add 14H plus. Now we'll multiply with my electrons, balancing electrons. Next step is what? Balancing electrons. This is 14H plus. 14H plus. So 6 electrons here, 2 electrons. So multiplying this equation with 3 and this equation with 1. So final equation. So 6 iodine minus usage to 3 iodines plus 6 electrons. And now combine these two equations and finally you'll get the answer. Let us see the answer now. So 6 potassium iodide. So 6 iodine minus changes to 6 potassium iodide and 14 HCl. Since 14 H plus we have taken, that is changing to 14 HCl. Just see here, clearly you can understand. 14 HCl is there, so 14 CH plus. And here, and 2 Cr plus 3. So 2 Cr Cl3 plus 3 changes to Cl3. That's all. Nothing is there. And 7H2O. Just we have to write this equation in ionic form. Then we have to balance. And in place of iodine minus, we have to keep potassium iodide. And in place of Cr plus 3, we have to keep Cl3. And iodine is 3 moles of iodine as is we got here also. 6 and 6 electrons will get cancelled. And 7H2O. That is how many water molecules? 7 water molecules. So here I have written 7 water molecules and 8 KCl. So it is nothing but how? It is 8 KCl potassium chloride because here we'll get 7H2O and potassium chloride also you'll get 8 KCl because totally we are adding 6 and here and 2. So totally automatically you'll get 8 KCl. So I hope it is clear. So we have to use the balancing the following reaction by ion electron method. First we have to write the given molecular equation into ionic equation. Ionic equation means the one which is undergoing change in oxygen state, that only we have to represent. And depending on acidic medium or basic medium, we can write adding of water molecules and adding of OH minus ions or adding of water molecules to other side H plus ions. Acidic medium, H plus ions, basic medium, OH minus ions. And as it is, we have to do by ion electron method. After combining this complete equation, substitute here itself. Automatically, you'll get the answer. I hope it is clear. Next. So here K2Cr2O7, 6 Ki, because 6 iodine minus we got. Since we got 6 iodine minus, again I'm writing here, since we got 6 iodine minus, so 6 Ki. Since we got 14 H plus, so 14 HCl. And since we got 2 chromiums, so 2 chromiums. And 2 Cr plus 3, we got 2 Cr plus 3. So in place of plus 3, we are taking CrCl3. And we got iodine, so 3 iodines we got already. So 3 iodines we are keeping here. And 8 moles of potassium chloride. This is only here defined. Why we got 8? Because already chlorines are here, 14 chlorines are there, and here only 6 chlorines are there. So remaining 8. And potassium is 2 plus 6, 8. So 8 simply. And we are what we have got, how many water molecules we added to the side deficit of oxygen atoms, add equal number of water molecules. So we have added 7H2O. So automatically you'll get the answer. So this is called balance the following equation by ion electron method. Very, very important. They'll ask in the examination. Please note it down. I hope it is clear. Next. Balance the following equation by ion electron method. Again, here also same thing. Here itself, I'll show you now. So silver, it is changing from 0 to +1 because nitrate is -1 because NO3 is -1. So silver is undergoing oxidation because it is increasing oxidation number. And nitrogen here it is +4 because 1 plus 3, 1 minus 6, it is +5 actually, sorry. So it is nitrogen is +5. How you got +5? I'll show it now. Again recapping, so hydrogen is +1, x minus 6 is equal to 0, so x is equal to +5. So for nitrogen, the oxygen state of nitrogen is +5. So 0 +5 +1 and nitrogen oxide. Here, what is the oxygen state of nitrogen here? And here we will take directly nitrogen plus 5, and here it is changing to plus 4. What is it? Sorry, plus 2 only, because only one oxygen. And here it is changing to nitrogen 1 minus 6, it is plus 5. So here it is no need to change, so no need to write here. Just only we have to identify this only, because there is no change in oxygen state of nitrogen here. So straight away we will be writing plus 1 for silver, and nitrogen is plus 2. So it is 5 to 2 decrease in oxidation number, and this is 0 to 1 increase in oxidation number. So 0 to 1. So again, I'm wrapping this. Yes, 0 to 1. So it is 0 to 1 increase in oxidation number. So this is oxidation, and this is reduction. It's called what? Reduction. So straight away you take this skeletal equations. So Ag changes to Ag plus. That is oxidation half reaction. And say nitrate. So what is this? Nitric acid changes to nitric oxide. That is reduction half reaction. Reduction half reaction and oxidation half reaction. So here are three oxygens. So we have to next, as it is balancing electrons. So silver should lose one electron to form Ag plus. So it is one electron. Similarly, nitric acid, how many electrons? This is plus 5 changes to plus 2. So 3 electrons. So nitric acid should gain 3 electrons to form nitric oxide. Now we'll write water molecules. To the side deficit of oxygen atoms, add equal number of water molecules. So this equation can be written as, here I'm writing, please note it down. HNO3, this is RHR, I'm writing reduction half reaction. HNO3 plus 3 electrons. Some gap you have to keep because you have to add H plus ions. So HNO3 plus 3 electrons gives H2, nitric oxide. So here how many oxygens? One oxygen, and here 3. So we have to add 2 water molecules. How many water molecules? 2 water molecules. So straight away 2 water molecules you get here. So 2 water molecules. And here 3 electrons, and here 2 water molecules. And the other side, since we have added 2 water molecules, one H is there. So we have to add only 3 H plus. How many H plus? 3 H plus. Very, very important. So that 3 H plus becomes 3 HNO3. Now, this is 3 electrons and this is 1 electron. So this equation with the 3. So we'll get finally 3Ag gives rise to 3Ag plus 3 electrons. So now we have to multiply this equation with 1. Now combining these two equations. So 3Ag, only reactants I'm writing, plus HNO3 plus 3 electrons plus 3 H plus gives rise to NO plus 2H2O plus 3Ag plus reactant products of the oxidation operation plus 3 electrons. So this 3 and this 3 gets cancelled. Add up these two equations, and HNO3 is 1 and here silver is 3. So automatically you'll get 3AgNO3, 3Ag. So 3AgNO3 means 3HNO3. So NO is only 1 and water is 2. So I hope it is 3. It is 3 again because 3 nitric acid are there. And this is 3 again, 3AgNO3 is there. And this is 1 NO plus 2 H2O. So total how many water molecules? Hydrogens are 4. So here it is 3. So we have to take one more hydrogen. So it should be 4 HNO3. Then only you'll get the answer, because 4 HNO3 you have to take, because it is 3 H plus plus 1 H plus. So totally 4 H plus. So 4 HNO3. So 4 hydrogens, 4 hydrogens. 3 silver, 3 silver. Nitrogen is how many? 4. So here it is 3 and here it is 1. Oxygens how many? 4 3s are 12 and here it is 3 3s are 9 and here 1, 10 and plus 2, 12. So finally this is the answer. So final equation I'm writing here. Please note it down. 3Ag plus 4HNO3 gives rise to 3AgNO3 plus NO plus 2H2O. This is the final equation. So we got it this, because 4H plus we got, 3H plus and 1H I already have taken. So it is 4H plus. So 4H plus. So 4H plus means nitric acid. 3 moles of silver combined with 4 moles of nitric acid to form 3 moles of nitric silver nitrate plus 1 mole of nitric oxide because only 1 mole is here it is formed, and 2 moles of water because we have got 2 moles of water here, and so on. I hope it is clear. Please note down. This is the final equation. So this is called balancing the following equation by ion electron method. First, we have to discuss, how to separate the ion equation method. Simply, the one which is undergoing change, we have to take it out separately without the other added things. So silver is changing to silver plus ion because it is plus 1. So simply I have taken silver to silver plus, and nitric acid changes to nitric oxide. So that's why I have taken HNO3 changes to HNO because plus 5 state to plus 2. Now balancing the reaction in acidic medium, since nitric acid is acidic medium. So to the side deficit of oxygen atoms, add equal number of water molecules. So here 3 oxygens and here 1 oxygen. So we are multiplying with 2 water molecules, and to other side add equal number of H plus ions. So why I have taken here, actually you should multiply with 4 H plus, but here already 1 H is there, so simply I have taken 3 H plus. So 1 plus 3, total 4. So that's why I have taken 4 moles of nitric acid. It's very, very important and easy also. I hope it is clear. So please note down. Now you can see the answer. As I told you, 3 moles of Ag plus 4 moles of nitric acid gives us 3 moles of Ag and NO3 plus 1 mole of NO plus 2 moles of H2O. I hope it is clear. So this is called balance the following equation by ion electron method. Again, the same thing. So balance the following equation by ion electron method. So here they have to mention acidic medium and basic medium. So simply we'll check now. So iron does not change any oxygen state, only tin is changing. Since tin is plus 2, changing to plus 4 state. Remaining nothing is changed because iron is plus 3 state and here it is plus 2 state. So simply we'll write here Fe plus 3 changes to Fe plus 2 and Sn plus 2 changes to Sn plus 4. So simply we have to do like this. So you'll get the answer easily. Simply, since it is 1 electron change and this is 2 electron change, so it should gain 2 electrons. Sn plus 2 should gain 2 electrons to become Sn plus 4. And this is Fe plus 3 should gain 1 electron to become Fe plus 3. So it should lose 1 electron. Fe plus 3 changes to Fe plus 2 plus 1 electron. Now this is 2, this is 1, so multiply this with 2. So 2 Fe plus 3 gives rise to 2 Fe plus 2 plus 2 electrons because we have to do electrons balancing, and this becomes only 1. Sn plus 2 plus 2 electrons gives rise to Sn plus 4. Now adding, so equating the both equations, that is 2 Fe plus 3 plus Sn plus 2 plus 2 electrons gives rise to 2 Fe plus 2 plus 2 electrons plus Sn plus 4, equating on both sides. So these 2 electrons gets cancelled. So finally, for iron, you'll get 2 and nothing you'll get it. Now you can see here easily because for tin, it is only 1. It is only 1 both sides. So straight away, the answer is 2 FeCl3 plus SnCl2 gives us to SnCl4 plus 2 FeCl2. Here, how many chlorines? 2 into 3, 6. And here, 2 to 4, 4 plus 4, 8. And here, 2 more chlorines are there, so 8. Now, 1 tin, 1 tin. 2 irons, 2 irons. So it is balanced. So final answer is 2 FeCl3. Why we have taken 2 FeCl3? For balancing electrons, we got 2. We have to multiply with 2 plus SnCl2 gives rise to 2 SnCl4 as it is, because for tin also right hand side only 1, plus how many ions are there? 2 FeCl2 plus 2 state means Cl2. That's all. So this is the answer. I hope it is clear. So this is called balance of ion equation, following equation by ion electron method. Let us see the answer now. Please check it. So 2 FeCl3 plus SnCl2 gives us to SnCl4 plus 2 FeCl2. I'll clear the drawings. You can see here. It's very, very easy and easy to understand. I hope it is clear. Next. So now I'm going to take the summary of the chapter because we have done already. This chapter is completed. Now I'll be taking the summary of the chapter. Let us take now summary of the chapter. So in this chapter, what we have done so far, let us see now. Very, very important chapter, summary of the chapter now. Just I'm writing it here because there is no space. I have not taken any empty slide. So just I'm writing here the summary of the chapter. Please note it down. Summary of the chapter. First, what we have done, what are redox reactions? To identify which is reduced, which is oxidized. Redox reactions. Second, what we have done, balancing redox reaction, oxidation state and oxidation number. Oxidation state to find the oxidation state of sulfur in H2SO4 like that. Oxidation state or oxidation number. This is very, very important concept. Third, we have done balancing of redox reactions by various methods. Balancing of redox reactions. In that, we have done 3 types. What is that? First one, oxidation number method. Second one, ion electron method. And third one, partial equation method. Partial equation method. So all these 3 are very, very important. So partial equation method. So all these 3 are very, very important. And you will get questions only based on this third and second one only. So oxidation number method, we have done both in acidic medium as well as in basic medium. Partial equation method, we have done potassium permanganate, potassium dichromate reactions, which are very important, nitric acid and even halogens. And lastly, we have done given molecular equation, we have to change into ionic equation, then we have to do balancing. It is also very easy method. That is also we have done in acidic medium as well as in basic medium and neutral medium also. So all these topics are very important. From redox reactions, it is main basic chapter. So definitely you'll get 2 questions for any competitive exams, either NEET or JEE or may or advanced. So please follow all these things. Whichever doubts you have, you can ask me when we are taking the live class. So I hope it is clear. Very, very important. Second is very most important, that is finding oxygen state. Calculate the oxygen state of sulfur in H2SO4. Calculate the oxygen state of iron K4FeC and taken 6 times like that. They'll ask so many questions based on oxygen states. And also balancing of redox reactions. Types of redox reactions. In this we have to underline disproportionation reaction. That is very, very important because the same element is undergoing oxidation as well as proportionation reaction is most important. Types of redox reactions. In this combination, displacement is easy, but disproportionation is very, very important. What is disproportionate reaction? The same element is undergoing as oxidation as well as reduction. That's why it is called disproportionation redox reaction. Examples are also very, very important. So please note it down and follow what we have done. And whatever the slides are given to you, please make it as a notes in your classwork. If you write the slides matter and do the numericals as it is, like how what we have done in the lecture, you can do it easily and easily you can understand. I hope it is clear. So we are discussing now. We have completed this redox reactions. So finally, we have completed these redox reactions. This chapter is most important. So I'm stopping the class. I'm completing my class. So this chapter is most important. Please note it down and do accordingly. So if you want, I'll do some previous NEET questions now itself. I'll do now. Let us see now some previous questions. Question number 1. Question number 1. Important questions they'll ask. So here itself I'm writing the heading. Previous competitive exam questions. Previous competitive questions. Competitive exams. Exam questions. So first question. Question number 1. Select the correct statement in the following reaction. Question number 1, I'm writing here again. I'm doing it. Question I'm writing with right the select the correct statement. This is previous NEET question. Select the correct statement in the following reaction. In the following reaction. First, the reaction is NH4 and O2. That is ammonium nitrate on decomposition forms N2 plus 2H2O. First statement, what they are given. Oxidation number of nitrogen is oxidation number of nitrogen has changed from -2 to +2. Second option. Oxidation number, that is O dot N, of nitrogen in NH4 plus change it from -3 to 0, change it from -3 to 0, and that in NO2 minus, and that in NO2 minus, change it from -3 to 0. In both cases, they have given -3 to 0. Let us see. Next, third option. Oxidation number of nitrogen. Oxidation number of nitrogen in NH4 plus, change it from +1 to 0, and that in NO2 minus, change it from -1 to 0, change it from -1 to 0. So fourth option, none of the above. So here what happens, ammonium nitrate, NH4 and O2 changes to NH4 plus NO2 minus. So in this H4, NH4 plus, and here NO2 minus. So it is +1 and it is -1. So -1 to 0, +1 to 0. So answer is third option. -1 to 0, because here it becomes 0. And in this minus, here it is +1 and here it is -1. And finally it becomes 0. So it is very simple, like these questions you'll get. Now question number 2. Let us take question number 2, which is not the disproportionation reaction. Which is not the disproportionation reaction. Previous completer. Option 1. First option was given 3H3BO2 gives rise to 2H3BO3 plus PH3 phosphine. Second equation, they have given HCH4 that is formaldehyde, plus OH minus, that is basic medium, that is KOH also you can take, use H2, HCO minus plus CH3OH, methyl alcohol. Third equation, NH4NO3, that is ammonium nitrate, changes to N2O plus 2H2O. And fourth equation, 3Cl2 plus 6OH minus gives H2, 5Cl minus plus ClO3 minus plus H2O. So in this clearly we can say here, what is disproportionation reaction? Same element is undergoing oxidation as well as reduction. Let us see here, phosphorus is changing. What is the oxygen state of phosphorus? 3 plus, so here I'm calculating H3PO2 oxygen state of phosphorus. Yes, I'm writing here example. So 3 plus x minus 4 is equal to 0, implies x is equal to 1, that is plus 1. And here it is changing to H3PO3. So H3PO3, I'm doing oxygen state of phosphorus. So 3 plus x minus 6 is equal to 0, implies x minus 3 is equal to 0, implies x is equal to plus 3. So it is changing from plus 1 to plus 3, and here it is minus 3. So plus 1 plus 3 minus 3. So it is a disproportionation reaction. Second one, HCHO plus OH minus gives us HCO minus CH3OH. Here no change in oxygen states for anything changing taking place. So it is not a disproportionation reaction. So answer is second option. Third also nitrogen, NH4 plus and NO3 minus. So here the oxygen state of nitrogen is plus 1 and here it is minus 1. So it is changing to 0. So like this we have seen in the previous example. So NH4 plus and NH4 NO3 minus. So automatically it is also changing to N2O, that is plus 4. Sorry, plus 1. It is plus 1. So plus 1 minus 0. So it is also disproportionation. This is also clear. Chlorine 0 changes to minus 1 and here it is plus 5. So this is also disproportionation. So only answer is second option. I hope it is clear. Like these questions you'll get, which of the following is not a disproportionate reaction. Next, question number 3. Question number 3, these are all previous competitive questions. In the reaction, Cu plus H2SO4 gives rise to CuSO4 plus, in the reaction Cu plus H2SO4 gives rise to CuSO4 plus H2O plus SO2. SO2. Correct statement they're asking. First option they are given. H plus is oxidizing agent. H plus is oxidizing agent. What is an oxidizing agent? It brings about oxidation to others and itself undergoing reduction. Second one, SO4 2 minus is the oxidizing agent. Is oxidizing agent. And third one, both are correct. And fourth one is the option, none. So in this case, copper oxidation state is 0, changing to plus 2. So it is increasing oxidation number. So it is undergoing oxidation. And sulfur, it is plus 6, changing to plus 4. So decrease in oxidation number. So it is undergoing reduction. So sulfate ion is the oxidizing agent. Only B is right option. H plus is not changing anything because it here plus 1 and here also plus 1. So only sulfate ion, because it is changing from plus 6 to plus 4, it is undergoing reduction. The substance which is undergoing reduction brings about oxidation to others. So sulfate ions is bringing oxidation to copper. So automatically sulfate ion is the oxidizing agent. I hope it is clear. So this is second question number 4 now. Next question. The oxidation number of chlorine. Oxidation number of chlorine in bleaching powder is bleaching powder is first option A, it is -1 and +1, -1 and +1. Second option B, it is 0 and +1. Third option is +1 and +1. And fourth option, that is D option, it is 0 and -1. So already we know bleaching powder formula is, what is the formula of bleaching powder? It is calcium oxychloride, CaOCl2. CaOCl2. So calcium oxygen state is +2, oxygen is -2. Here itself it is becoming 0. Then this should be definitely +1 and as well as -1. So answer is -1 and +1. I hope it is clear, because all the oxygen states, sum of the oxygen states of all the elements is equal to 0. So totally should be 0. Anyway, we know calcium is +2, oxygen is -2. So definitely these two chlorines should have -1 and +1 as these respectively. So +1 and -1. So answer is first option. I hope it is clear. So like these questions you are going to get in the examination. So please do it. So this is the summary of the chapter. So I hope it is clear. So all the topics in this chapter is very, very important. So please note it down. Thank you all.